Hello there. I'm glad you're here. You've made it to the quiet part of the day. The part where the world slows down and thoughts don't need to be solved, just softened. So take a deep breath, let your shoulders fall a little, and let's begin not with a bang, but with a flicker. And if this little journey helps you drift off, feel free to follow along each night. There's a whole universe of boring science waiting patiently to help you rest. You can even tap follow or subscribe if you'd like this kind of calm to return tomorrow. Now, it starts small, as most wonders do. A glow in the corner of your room. Maybe it's a street lamp peeking through the curtains. Maybe it's the tiny dot of your phone charger, softly breathing blue in the dark. Whatever it is, it's not darkness. It's something else. You roll onto your side, and as your eyes begin to adjust, the light remains gentle, unbothered, patient. It waits, quietly offering its presence without ever making a sound. And so tonight, we're going to talk about that soft, silent visitor. That shimmer on the wall, that thread connecting stars to your bedroom window, that strange something we call light. But what is light, really? Is it a thing? A force? A feeling? Is it the warmth you feel on your skin in the morning? Or the flicker behind your eyes when you close them too tight? Is it a wave rolling across space? Or a particle too small to touch? The truth is, light doesn't like to be one thing. It likes to pretend, to shimmer and hide, to travel and reflect, to touch everything without ever needing to be touched. And tonight, in the soft stillness of your room, we'll walk alongside it. Not with urgency, not with calculations, but with quiet curiosity. Because light, well, it's everywhere. But it's also full of secrets. And this is a safe space for secrets, isn't it? So, if you're ready, let's dim everything else. Let your breath fall into that slow, sleepy rhythm. Let the shadows stretch a little longer. And let your imagination gently follow a beam of light. Out of the room, up past the rooftops, above the clouds, towards something ancient and luminous and still very much alive. This is boring science for sleep. And this time, we're chasing the softest mystery of all. Imagine you're in a cave. Not a spooky one. Not the kind filled with dripping echoes and bats. No, this one is still, quiet, deep below the surface of everything. There's no wind, no sound, and most importantly, no light. Not even the faintest shimmer. Your eyes, open as they are, have nothing to see. And in that absence, you begin to wonder if seeing ever existed at all. Then, a spark, just a little one, like someone far away has struck two stones together and, for a moment, light was born. It doesn't last long. It flickers once and disappears again. But now you know, you're not alone in the dark anymore. Something else is in here with you. Light, at its very beginning, often feels like a whisper. It's not loud, not boastful. It doesn't arrive with drum rolls or thunder. It just appears, softly, gently, and yet it changes everything. You don't have to understand what it is to know that. Even a baby newly arrived in this world will blink at the Sunday, not because they've learned anything about optics or wavelengths, but because light is felt even before it's explained. Maybe your first memory of light is just that, a soft glow creeping in through a half-open door. The way it used to crawl across your bedsheets in the morning, long before you were ready to wake up. A beam catching dust in the air, turning every speck into a golden little galaxy. It never had to say a word. Light just was. And that's how we all meet it, really. Not in a lab, not through equations, but in the everyday poetry of things revealed. But here's a curious thing. Light is, somehow, both very obvious, and also very strange. You flip a switch, and there it island. Simple, reliable. Yet when you start to ask, what exactly is it? The answers turn into riddles. Light is not made of matter. You can't weigh it. You can't hold it in a jar. It travels like a wave, rippling through space. But also, it acts like a particle, a photon, something that arrives in packets. It doesn't need air to move through. In fact, it prefers a vacuum. It can go for years, centuries, millennia, never touching anything, just moving forward. Like a letter with no return address. Like a dream drifting from star to star. Light carries messages across the universe, and sometimes those messages arrive right at your eyelids when you're just trying to fall asleep. Let's go back, not just to your cave, but to a time before people even had fire. Long before lamps, before candles, before anyone had tried to make light. There was only one source: the sky. The sun rose, the stars came out, and early humans looked up and saw something more than black. They saw flickers, they saw patterns, they saw movement, and maybe they didn't know the word for light, but they knew it meant safety, or change, or time. Light told them when to sleep, when to wake, when to go hunting, when to stay home. It painted shadows that looked like monsters, but also helped them find berries and rivers and shelter. Even then, before we understood anything, we listened to light. Because light doesn't speak in words. It speaks in presence, in warmth, in gentle arrivals. Now come back with me, just for a moment, to a match in your hand. You strike it. That hiss, that glow, that's a chemical reaction. Heat, friction, oxygen, feeding flame. But the light you see? It's not the fire itself. It's energy being released in a particular way. Atoms excited, electrons jumping to higher levels and then falling back, releasing little bursts called photons. Each photon is a tiny, massless traveler. A visitor without feet or wings, just pure momentum moving at the fastest speed the universe allows. And when that photon reaches your eye, it doesn't bump into you like a raindrop. It's absorbed. Right there in your retina, your cells catch the photon and translate it. They turn it into an electrical signal which moves through nerves into your brain, where it finally whispers. Yellow, bright, warm. That whole process takes less than a blink, less than a thought, but it's everything. It's how you see a candle, a sunset, a book page, the face of someone you love. So maybe the first time you meet light isn't in a cave or through a match, but through your own eyes, every single day. You've been meeting light over and over again, since before you had the words for it. It comes through windows and under doors. It slips past curtains. It dances on water. It reflects in mirrors. It changes the colors of leaves. It tells birds when to migrate. It tells flowers when to bloom. It tells you, quietly, when morning has come. And all the while, it asks for nothing in return. Light doesn't demand to be noticed. But when it is, it becomes the stage for everything else. Without light, colors have no meaning. Without light, time feels stuck. Without light, we lose our sense of direction, our rhythm, our connection to the outside. And yet, light is not loud. It doesn't need applause. It doesn't even linger. It simply arrives, and then goes. And maybe that's why it feels a little sacred. As you lie there now, eyes heavy, you can still feel the faint glow through your eyelids. Not sharp, not distracting, just there. A gentle reminder that something ancient and invisible is still quietly surrounding you, still traveling, still reflecting, still being itself, even as you drift away. So for tonight, don't try to hold it. Don't try to solve it. Just let it flicker. Let it glow. Let it guide you. not to answers, but to rest. Let's imagine you're floating, not swimming, no splashing, no movement of limbs, just drifting in a space so still you can't even feel what's up or down. It's dark out here, quiet. There's no wind, no floor beneath you, and nothing solid in sight. And then something passes by. You don't hear it. You don't touch it. But if you had the right kind of eyes, the kind that can sense more than just brightness, you'd know something just moved through you. It didn't push, didn't carry mass, but it was energy, pure and unburdened. That, right there, is light. And here's the beautiful contradiction. It's a traveler that carries no weight. You might think of light like you think of sound, a wave rippling outward from its source. And in some ways, it is a wave. It has a frequency, how quickly it wiggles. It has a wavelength, how far apart its crests are. And depending on those, your eyes see different colors. Slow waves give you red, faster ones give you violet. But unlike sound, light doesn't need air. It doesn't need water. It doesn't even need anything. It moves through vacuum, through the cold, black emptiness between stars, just as easily as it travels through glass or skin or oceans of atmosphere. And here's where it gets odd. Waves usually need something to wave in. But light, it waves itself. Back in the 1800s, people were confused by this. How can it be a wave, they asked, if there's no medium? So they invented one. They called it the luminiferous ether, a mysterious invisible substance that filled all of space, just so light would have something to travel through. It made sense. Until it didn't. Eventually, clever experiments, like the famous Michelson-Morley test, proved that no such ether exists. Light didn't need a medium. It just was. A wave without water. A ripple without rope. A traveler without shoes. But here's where it gets even stranger. Sometimes, light doesn't act like a wave at all. Sometimes, it acts like a little dot. A photon. A packet. A particle. It can hit a metal surface and knock loose electrons, like a cue ball in a cosmic game of billiards. It can strike a solar panel and release energy. It can be counted, one by one, as it enters a detector. Wave or particle? The answer is yes. Light is both, and neither, and something else entirely. Let's pause there for a moment. You're lying still now. Maybe the room is a little cooler than before. Maybe your breath is slower. Just imagine, in the soft dark behind your eyes, a single beam of moonlight stretching across your room. Now split it in two. Send one half to the left, one to the right. Let them wander for a bit. Then gently bring them back together. What happens? If light were made of tiny bullets, they'd just land in two neat piles. But because it's also a wave, something magical occurs. They interfere. Some crests line up, growing taller. Others cancel out, disappearing completely. What you get isn't just two lights. You get a pattern, a delicate zebra of bright and dark stripes called an interference pattern. This is proof. Light behaves like a wave. But then, you make the light dimmer. So dim, only one photon at a time is sent through. Surely the interference should vanish, right? And yet, it doesn't. Even when there's just one photon, it still creates the same pattern, as if it interfered with itself. How can something interfere with itself? Unless it's going both ways at once? Unless it's not a thing but a possibility? Unless it's not just where it is, but everywhere it could be? That's the wonder of quantum light. It's not just a traveler. It's a traveler who hasn't made up its mind. You can't say exactly where it island, only where it's likely to be. It's like trying to find a cat in a mansion by listening for soft purring, but the cat is purring in every room until you actually open a door. Until you look, And the moment you look, the cat picks a room, the light picks a path. The wave becomes a particle. The maybe becomes a here. Now come back to Earth, just for a moment. You're in a park. Early morning. The trees are still wrapped in mist. A shaft of sunlight slips between the branches, catching the fog like a ribbon of gold. What you're seeing is a stream of photons, each one launched from the surface of the sun 8 minutes ago, traveling across 150 million kilometers, just to scatter off a water droplet in front of you. That light is ancient. It survived solar flares, passed through space untouched. And now, here it is, painting the air for you. You blink, and it's gone. Because that's the thing about photons. They only interact once. They are single-use travelers. No bouncing back, no second tries. They arrive. They say hello, and then they vanish into memory. So what is light, really? A wave? A particle? A ghost? Einstein helped us take a step forward. He showed that light isn't just strange, it's quantized. Photons don't come in half steps. They carry very specific amounts of energy, like coins of light, with fixed denominations. Red light carries less energy than blue. Ultraviolet carries more than visible. Gamma rays? They're like light, with the volume turned all the way up. And you? You're constantly bathed in all of it. Every color, every temperature, every silent arrival. You may never see a photon with your bare eyes. You may never touch a wave. But tonight, maybe you feel something different. The room around you glows gently. A clock face, a dim lamp, a moon through the window. Each flicker, each glow, a reminder that light is both science and something close to poetry. A messenger that never rests, a puzzle that never settles, a traveler with no weight. Picture yourself standing in a wide, silent valley. There's no wind, no birds, no hum of traffic, just stillness, stretched out in every direction like a great, empty sheet. Then, imagine tossing a pebble into a perfectly calm lake. The ripples roll outward, graceful and smooth. Each wave travels through the water, needing that surface to carry its motion. No water, no waves. It's simple, right? But now, take away the lake. Take away the valley. Take away the earth beneath your feet. Let yourself float in the blackness between stars, in the vacuum of space. No air, no molecules, no stuff at all. And yet, light still moves. Not just slowly drifting or falling like dust, but racing. At over 299,000 kilometers per second, in perfect silence, in perfect emptiness. How? That question puzzled some of the greatest minds for centuries. Because in our world, motion needs something to move through. Waves need water. Sound needs air. A violin string needs tension. Even people need a floor beneath their feet to walk. So how does light move when there's nothing under it? How does it travel from the sun to your skin across millions of kilometers of literal void? And the answer is that light is not like anything else. It is the medium. To understand this, let's go small, tiny small, shrinking yourself down past cells, atoms, electrons, until all you see is the emptiness between the emptiness. Out here, in the deep quiet of the subatomic world, most of what exists doesn't take up space. Particles pop in and out of nothing. Fields stretch across the universe, invisible and unbending. And in this strange realm, light lives as a self-propelled disturbance in two fields, an electric field and a magnetic one. Imagine two dancers, one moving left and right, the other spinning top to bottom, but both always perfectly in sync. That's light. An electric field vibrating in one direction, and a magnetic field vibrating in another toke, perpendicular to each other, moving forward together like a pair of tightly choreographed waves. They don't need anything underfoot, because they create their own floor as they go. Think of it this way. Most travelers ask for a path. Light builds its own path, one vibration at a time. It's like a tightrope walker who brings the rope with them, unrolling it step by step as they cross the sky, never pausing, never falling. Each flicker of the electric field creates a magnetic flicker, which in turn creates the next electric flicker, and on, leapfrogging through space. It's a self-sustaining dance. And in a vacuum, with nothing to slow it down, light reaches its maximum speed, the universal speed limit, the speed of light. Not because it's in a rush, but because there's no resistance, no friction, no noise, just pure, uninterrupted travel. But here's something strange. If you were to chase after light, go faster and faster in a spaceship, try to catch up with a photon, you'd never quite get there. No matter how fast you go, light always seems to stay ahead, moving away from you at the same speed. This idea bothered scientists for a long time, until a quiet man with wild hair came along and turned the whole world inside out. Albert Einstein. Einstein's theory of special relativity told us something astonishing. The speed of light is not just fast, it's constant. It doesn't care about your motion. Whether you're running toward it or away, the light still hits you at the same speed. To make that possible, space and time themselves must stretch or shrink to compensate. Time dilates. Distances compress. The very fabric of reality bends, just so light can remain itself. All of that, just so this strange traveler can keep moving through nothing, without ever slowing down. Back in the 1600s, people thought light must bounce off tiny particles in the air, that it needed the stuff around it to spread, like perfume in a room. Others thought it must ripple like waves in water, requiring some cosmic fluid to move through. So they invented the ether, an invisible ocean that filled all space, perfectly weightless, perfectly still, perfectly undetectable. It sounded elegant, until it didn't work. In 1887, the Michelson-Morley experiment tried to detect the ether by measuring the speed of light in different directions, like feeling for wind through a moving car window. But they found nothing. No difference. No ether. Just light, moving through nothing at exactly the same speed every time. And so the idea of a medium was abandoned, because light didn't need one. It didn't borrow space. It defined it. So what does that mean for you, as you lie here now? It means that the light touching your skin, even the faintest moonbeam brushing across your blanket, traveled here without support. It didn't float on air, didn't ride a current. It moved through literal emptiness, space that held nothing, not even a whisper of a molecule. And yet, light still danced its way across the cosmos to reach you. Quiet, steady, on time. Now imagine a photon, just one, born in the nuclear heart of a star. It takes thousands of years to bounce its way from the star's center to the surface, scattering, ricocheting, like a pinball trapped in a glowing machine. And then, freedom. It escapes. And from that moment, from that burst of liberation, the photon never slows down again. It travels billions of kilometers, over decades or centuries, never once stopping, never once aging. Because here's a curious fact. For light, time doesn't pass. At the speed of light, clocks stop ticking. From the photon's point of view, it is born, and then it arrives. No journey, no delay, just here to there. Which means that moonlight reaching your face tonight, to the photon, it left the moon and touched you in the same instant. Time folded. Space vanished. That's the gift of a traveler who needs no path. So the next time you see a beam of sunlight slicing through a dusty window, or a car's headlights slicing the mist, or a star winking at you across the galaxy, remember what you're really seeing. You're not watching something move through space. You're watching space respond to motion itself. You're watching light do what it's always done. Move forward, without weight, without rest, without asking permission, just dancing through nothing. Let's begin with something ordinary. You're pouring a glass of water. Nothing special, just a clear stream arcing from pitcher to cup. But then, as sunlight sneaks through the kitchen window, the rim of that water catches it, bends it, scatters it, and for a brief second, you see it, a flicker of color, a sliver of rainbow trapped in the curve of glass. It disappears before you can point it out, but it was there, and it reminds you of something strange. White isn't what it seems. You grow up thinking white is nothing, or maybe everything. It's the color of blank pages, empty skies, hospital walls, clean laundry. But white, true white, is not empty. It's crowded, overflowing. Because white light is not a single color. It's a symphony, a whole chorus of wavelengths, all singing at once, so fast, so balanced, that your eyes blur them into a single experience, brightness. But when white gets bent, when it passes through water, glass, or even tiny raindrops, it splits. And that's when you see the hidden voices. Red, orange, yellow, green, blue, indigo, violet. A rainbow. A revelation. The song of light in separate notes. Imagine a beam of white light as a marching band. All the colors are walking side by side. Different uniforms, different steps, but perfectly in sync. Then they reach a puddle, or a prism, or a curved surface of water. And something curious happens. The puddle doesn't treat all colors equally. It bends each one differently. Red, with its longer wavelength, takes a wide, lazy arc. Blue, with its shorter wavelength, dives tighter, sharper. By the time the band exits the puddle, the members are no longer side by side. They've fanned out, like a bouquet tossed into the air. What you see on the other side is the rainbow that was always hiding inside the light. Now imagine a raindrop, a perfect little globe, falling through the sky. As sunlight hits it, some of the light goes in, bounces around inside like a trapped whisper, then exits, bent, split, and scattered. Multiply that by millions of raindrops, each one bending and reflecting light at just the right angle, and you get a rainbow stretched across the sky. But here's the quiet magic. The rainbow isn't in the sky. It's in your eyes. No two people see the exact same rainbow. Because it depends on where you're standing, which raindrops are reflecting light to you, and at what angle your head tilts. A rainbow is real, but also personal, private, like a secret only light can tell you. Back in the 1602nd, a man named Isaac Newton darkened his room. He made a tiny hole in his shutters, let a beam of sunlight in, and placed a glass prism in its path. What spilled onto the wall wasn't just white. It was color. Bands, stripes, a spectrum. This shocked people. They had assumed colors were added to light. That maybe glass or water dyed it somehow. But Newton proved the opposite. Color wasn't added to white light. Color was revealed. White wasn't simple. It was a blend. A whole family of hues, crammed together so tightly they looked like one. So now you might be wondering, what exactly is color? Why does red feel warm, and blue feel cool, and green feel like spring? It all comes down to wavelength. Each color you see is light vibrating at a different speed. Red is slow, around 700 nanometers per wave. Violet is fast, closer to 400. Your eyes, complex little light detectors that they are, contain cells called cones. Each cone is tuned to respond best to certain ranges of wavelength. Some love red. Some adore green. Some only fire when they see blue. But here's the twist. Those cones don't just detect one color, they work together. When you see yellow, for example, it's not because there's a special yellow cone. It's because your red and green cones are activated at the same time, 8, and your brain says, "Ah, yellow, got it." Color is not just physics, it's interpretation. Now let's turn off the lights. Not in your room, but in your imagination. Picture a space with no light at all, no lamps, no Sunday, not even starlight. Total darkness. Do colors exist here? Well, they can. Because color isn't just what your eyes pick up, it's what your brain assigns meaning to. That's why you can see red when you rub your eyes. Why you feel blue on a rainy day. Why artists say color has emotion, even when no physics is involved. Light carries the signals, but you give them meaning. And maybe that's why rainbows make us pause. Because they're not just reflections. They're little miracles of arrangement. Physics that feels like poetry. Sometimes, light goes even further. It doesn't just scatter into a rainbow, it interferes with itself. Think of a soap bubble, shimmering, alive. That rainbow you see on its surface? Not from bending light, but from interference, waves of light overlapping, amplifying or cancelling each other, depending on the thickness of the bubble. A film just nanometers thick can turn clear water into a peacock of colour, because light is always hiding more than it shows. Even materials that seem white may not be. White paint? It scatters all visible wavelengths equally. But pearls? Opals? Feathers? They reflect and scatter light in ways that play tricks on your vision. Tiny structures in their surfaces bend light at just the right angles to produce shifting colours, not through pigment, but through structure. It's called structural colour, a reminder that sometimes beauty isn't in what something is, but how it handles the light that touches it. So tonight, as you lie back and let your eyes drift closed, know that even behind your lids, a light is remembered. Colours are stored. Spectra echo quietly in your brain. That last glimpse of your room, your walls, your blanket, your lamp, still hums somewhere deep inside you. Because light doesn't just pass through the world. It leaves impressions, faint fingerprints of colour and contrast, moments you carry even as sleep arrives. And in that stillness, the rainbow folds itself gently back into white. The prism vanishes. The marching band reunites. And once again, light returns to being a whole. The numbers are everywhere. 299,792,458 meters per second, or just the speed of light. A number so fast, it feels more like a legend than a measurement. It's one of those constants you hear in documentaries and textbooks. Revered, immutable, exact. But what does it mean? And why does it matter? That light moves so quickly? Let's slow everything down. Because to understand the speed of light, we have to approach it gently, like watching a train go by in the distance, noticing the way each carriage glides into the horizon. Not rushing, just realizing. First, some perspective. Light, in a vacuum, travels nearly 300,000 kilometers every second. That's fast enough to circle the entire planet more than 7 times, in the time it takes you to blink. If you shine a flashlight straight up, the beam could reach the moon in just over a second. Sunlight takes about 8 minutes to reach Earth. So the sun you see outside your window, that's 8 minutes old. You're looking into the past, not metaphorically, but literally. You live in light's afterglow. But why this speed? Why not slower or faster? The truth is, we don't know why the universe picked that number. It's simply island, a constant baked into the fabric of reality. It's not that light moves as fast as it wants. It's that nothing can move faster. This speed is a cosmic speed limit. And it's not just about light. It's about information, about cause and effect, about what can reach what and how quickly. Let's imagine a pond again. You toss a stone. Ripples spread outward, touching lily pads, insects, the edge. Now imagine a pond where ripples move instantly, where one splash affects the entire surface at once. You wouldn't get waves. You'd get confusion. No time. No delay. No order. That's why light speed matters. It creates structure, a pace, a delay, so that one event can ripple outward, reaching places in a predictable way. The speed of light is the universe's way of saying, not all at once, let things happen, in time. Here's something quieter to consider. Light doesn't feel fast to itself. In fact, from the light's point of view, time doesn't pass at all. If you were a photon, just imagine for a second, your entire journey, whether from a candle's flame or the edge of a galaxy, would happen instantly. You are emitted, and you arrive. No waiting, no middle, no ticking clock. Because time, as we know it, slows down the closer you get to the speed of light. And at light speed, time simply stops. It's not just fast, it's timeless. But does light always move that fast? Well, yes and no. In a vacuum, yes. Always. But introduce a material, air, glass, water, and things shift. Light slows down, not because it gets tired, not because the material resists it like mud, but because inside that material, light keeps getting absorbed and re-emitted by atoms. It's like walking through a crowd. You could run if the street were empty, but here you keep getting stopped for a second, tapped on the shoulder, redirected. Each individual photon still moves at light speed between atoms, but the whole process takes longer. So, in water, light slows to about 3/4 its original speed. In glass, even slower. And in something called a Bose-Einstein condensate, a special state of matter cooled to near absolute zero, scientists have even slowed light to just 17 meters per second. That's slower than a bicycle. But here's the twist. When light exits that slow medium and returns to vacuum, it instantly regains its full speed. It doesn't accelerate like a car ramping up. It just resumes, as if it was always meant to be that fast. No struggle, no loss, just the universe clicking back into its natural rhythm. Why does this matter? Because this is how lenses work, how glasses help you see, how telescopes magnify the stars. By slowing light just enough, just the right amount, in just the right direction, we can bend it, focus it, redirect it. Every time light changes speed, it also changes path. It bends. That bending, called refraction, is why a straw looks broken in a glass. Why rainbows curve. Why sunsets turn the sky red and the sea gold. Speed affects direction, and direction in turn affects everything we see. There's another strange twist to light speed. It isn't just how fast it goes, it's how it connects things. In Einstein's universe, distance and time are linked. Move through one and you affect the other, and the speed of light is the thread between them. It defines how space stretches, how clocks tick, how fast your thoughts can reach the stars. If you shine a light into space, it expands outward like a growing bubble. Everything inside that bubble can be touched. Everything outside can't. That bubble is called a light cone, and it defines your influence, what you can change, what you can reach. So in a way, the speed of light isn't just a number. It's a boundary, a gentle fence drawn around possibility. Now come back to your room. There's a small lamp glowing in the corner, or maybe just the moonlight again, casting shadows. And somewhere in that quiet glow, light is still moving, still stretching through space, still bouncing from surface to surface, still reaching your eyes, then your mind, then your memory. And though it may seem instant, the flick of a light switch, the flash of a thought, there is always a journey, always a space between start and finish. Light teaches us patience. It shows us that even something unimaginably fast still takes time. So tonight, let the numbers fall away. Don't worry about meters or seconds. Just imagine the feeling of something moving without delay, of messengers darting between stars, of a cosmos woven together by pulses of brightness, always arriving, never waiting, never late. Light doesn't need to rush. It simply is, fast, constant, timeless. Let's begin with a rainbow. You know the one, red at the top, violet at the bottom, stretching across the sky after a summer storm. It's beautiful, predictable, soothing. But have you ever wondered what happens beyond the violet or below the red? Do the colors just end? Does the spectrum stop at the edge of what we can see? The answer is soft and a little humbling. Number. It keeps going. The rainbow is not a wall. It's a window, and most of the light in the universe lies on the other side. You live in a tiny sliver of electromagnetic symphony, a narrow band called visible light. It ranges from about 400 to 700 nanometers in wavelength, just enough to produce the colors you know: violet, blue, green, yellow, orange, red. But if you step beyond either end of that band, if you follow the rainbow past its edges, you'll find strange and invisible forms of light, hiding in plain sight. Let's start on the red side, and keep walking. As you move deeper into the longer wavelengths, past red, past deep red, you enter the land of infrared. It's warm here. Literally, infrared light doesn't light up your eyes, but it heats your skin. It's the reason sunlight feels warm on your arm, even when the air is cold. It's how night vision goggles see in the dark, by detecting the gentle glow of warmth that all living things emit. Infrared is light you can't see, but you can feel, like a quiet presence in the room, like the way a person standing nearby can warm your side without ever touching you. Go further, and wavelengths grow even longer. You arrive in the world of microwaves. They're not just for reheating leftovers. These waves are cosmic messengers, used in communication, radar, satellite signals. They're also part of the oldest light in the universe, the cosmic microwave background. This soft hiss, this low glow, is the leftover light from the birth of the cosmos, 13.8 billion years ago. Too stretched to see, too old to warm, but still there, a whisper from the moment time began. Step even further, and you enter the vast plains of radio waves, the longest waves of all, some as long as a building, some as long as mountains. They carry your favorite songs through the air. They connect cell towers, satellites, submarines, but they're still light, still photons, just slower, wider, more patient. They pass through walls, through skin, through entire planets, and yet they go unnoticed, weaving the background hum of your modern world with silent, invisible grace. Now, let's turn around, back to the rainbow, back through red, orange, yellow, past green, blue, violet, and beyond. At the other edge of the visible spectrum, you find ultraviolet light. It's energetic, a little wild, a little dangerous. It's the reason your skin tans or burns under the sunday. It helps your body produce vitamin D. It sterilizes water and tools. It reveals hidden patterns on flowers, insect wings, and ancient paintings. Bees can see ultraviolet. To them, flowers glow with secret landing strips, patterns humans never notice. To some animals, the world is full of signals we miss, because their rainbow is wider than ours. And ours is just one version of the truth. Go further still, and you meet the powerful waves of X-rays. They pass through soft tissue, but not through bone. That's how doctors take a picture of your ribs, your teeth, your healing wrist. But the universe also uses X-rays to reveal black holes, neutron stars, supernovae. Out there, in the cosmos, X-rays pour from the edges of collapsed suns, from violent collisions, from hot gas spinning at unimaginable speeds, invisible, but full of energy, like lightning you can't see. And beyond even X-rays, there's one last edge, gamma rays. The shortest, the strongest, the most intense form of light. They're born in nuclear reactions, inside stars, inside bombs, inside the hearts of atoms. Too dangerous to feel, too fast to touch, they shimmer at the edge of destruction and transformation. And yet, they are still light, still part of the same family as the glow of a candle or the beam of a flashlight in the dark. Light is vast, vast enough to hold warmth and terror, music and memory, color and chaos. So why do we only see that tiny sliver in the middle? Because your eyes are tuned for survival. Visible light just so happens to pass easily through air and water, the environments life evolved in. If our atmosphere blocked it, we'd see something else. But we grew under these wavelengths. Red sunsets, green forests, blue skies. Evolution shaped us to see what's most useful, to not what's most complete. We are tuned to a window, a soft aperture between the deep radio thrum and the ultraviolet storm. But the universe, it plays the full orchestra. And here's the lovely thing. Even if you can't see this hidden light, you use it. You send text messages with microwaves. You cook with infrared. You get X-rays at the dentist. You watch the stars in ultraviolet. You hear the universe's heartbeat in radio waves. Your entire day is lit with invisible candles. Every moment, you're bathed in light you'll never see. But it's still there, still moving, still dancing. Tonight, as you rest your eyes, I know that the room around you is not dark. It may feel still. It may look empty, but it's full of light you cannot detect. Infrared warmth from your skin, Bluetooth pulses from your phone, Wi-Fi signals drifting like soft threads through the air. And from above, radio waves from distant stars, cosmic photons older than Earth itself, all whispering, all arriving, all carrying stories you'll never hear, but somehow still receive. So sleep now, in the glow beyond the rainbow, not with the light you see, but with the light that sees you, the gentle hum of a universe that never goes dark, only deeper. There's something comforting about a shadow, not because it hides things, but because it means something is there, standing between you and the light. A tree on the sidewalk, a hand on the wall, a cat curled on the windowsill. You may not see the object clearly, but its absence from the light tells you it's real. And in that way, shadows are not the opposite of light. They are its partners, its quiet companions, its soft reminders that light doesn't just reveal, it outlines, it shapes, it defines by contrast. Let's go back, just for a moment, to childhood. Remember the way the sun poured through your window in the afternoon? How it cast long shapes on the floor. Maybe you traced them with your finger, tried to step over them without touching them, or made your hands into puppets, dogs and birds and strange little creatures. All you needed was your hands, and light, and a wall, and suddenly darkness had meaning. A shadow is not a thing. It's a lack, a gap, a space where light could have gone, but didn't. It's not darkness by itself. It's darkness caused by something in the way. You see, light moves in straight lines. It doesn't bend around corners easily. So when something blocks its path, light stops, and the area behind the object remains untouched. That untouched region, that pocket of stillness, is a shadow. But not all shadows are the same. Some are soft and blurry, like the kind cast by clouds. Some are sharp and crisp, like the silhouette of a street lamp at noon. The difference comes down to the size of the light source and the distance from the object. A small, single light, like a flashlight, creates sharp, well-defined shadows, while a large, diffuse light, like the sky on an overcast day, softens the edges. Sometimes, a shadow is not one thing at all, but a gradient, a mix of penumbra and umbra, words that sound like spells, but simply mean partial and full shadow. You've seen it during an eclipse. The moon slides in front of the sun, and some parts of the earth fall into the penumbra, a gentle dimming. Others into the umbra, a sudden night. In that fleeting moment, day and night intertwine, all because of a shadow cast across space. Now close your eyes. Imagine standing in a canyon at dawn. The sky is turning from deep indigo to soft grey. Light begins to stretch its fingers over the ridges, slowly, cautiously. At first, you see only the top of the cliff's glow. Then the light descends, chasing the shadows downward, like water spilling over rock. It doesn't erase the darkness. It displaces it, because darkness doesn't fight back. It doesn't cling. It simply moves aside whenever light arrives. That's the quiet secret. Darkness isn't a substance. It's not stuff. It's not thick or heavy or cold. Darkness is what's left when light is gone. It's the default state of the universe. Light is the interruption, the miracle, the spark that says, I am here now, look. And yet, darkness has its own beauty. It's not just the absence of seeing, it's the presence of stillness. Without it, you'd never sleep, never dream, never feel the comfort of closing your eyes and letting the world fade. Artists use shadows to suggest mystery. Writers use them to evoke memory. Photographers use them to create depth, dimension, drama, because without darkness, light would be flat, featureless, blinding. We need contrast, edges, the gentle tension between what is seen and what is waiting. Now think of twilight, that soft in-between moment when the sun is neither fully gone nor fully present, when everything is touched by both light and shadow. You can't quite tell where one ends and the other begins. It's a moment made of gradients, like the hush between words, like the pause between breaths. In that half-light, your surroundings feel more poetic, not fully known, but not entirely hidden. The world becomes suggestion, not statement, and your mind begins to wander. In many ways, your brain works like this too. Your visual system doesn't just detect light, it interprets shadows. It uses contrast to define shapes, to detect motion, to focus attention. It fills in the gaps. That's why you can recognize a face lit from behind. Why you can read a book in dim light. Why a flickering candle still casts enough glow to comfort you. Your mind wants the interplay. It thrives on the push and pull between brightness and shade, between presence and absence. Even in nature, Shadow serves a purpose. Leaves overlap, casting dappled light on forest floors. Animals use shadow for camouflage. Nocturnal creatures move with confidence in the grayscale world of moonlight and faint glows. Even your own body uses shadows. Your pupils dilate and contract, not just to manage brightness, but to preserve contrast. You were built not just to detect light, but to navigate the space between light and dark. In some cultures, shadow is not feared. It's revered. Japanese aesthetics, for instance, celebrate yugen, the beauty of the mysterious and the unseen. A shadow in the corner, a glint of light on lacquered wood, the soft glow of a lantern inside a paper shade. It's not about revealing everything. It's about allowing space for wonder, for stillness, for rest. Tonight, your room is likely filled with shadows. Behind the bookshelf, beneath the chair, in the folds of your blanket. They're not hiding. They're simply waiting, gently cradling the edges of light. And as the glow from your lamp dims, or the moon shifts behind clouds, those shadows stretch, soften, settle. They do not rush. They do not ask for your attention. But they remind you, wherever light goes, darkness follows quietly behind. Not to threaten, not to steal, but to outline, to frame, to hold. So rest now, in the hush between beams. Let your breath match the slow exhale of twilight. Let your mind drift toward the edges. Light will return tomorrow. But for now, the shadows are here to keep you company. And in their quiet, you are seen, you are held, you are safe. There's something almost sacred about the way light touches things. Not in a loud, dramatic way, but soft, steady, almost shy. It arrives slowly through your window, slides across your bedsheet, warms your face in the early morning, and without saying a word, light begins its quiet work, not just helping you see, but helping you be. Because light doesn't just illuminate life, it sustains it, makes it, from the smallest leaf to your very own skin. Light is a silent sculptor, shaping everything it lands on. Let's start in a forest. Early morning. Mist hangs low between the trunks, and the leaves above are still, unmoving. Then, the sun rises, and, just like that, life begins. Tiny chloroplasts inside each leaf awaken. They've been waiting, and now they open their doors to the light. This process has a beautiful name, photosynthesis, from the Greek photo, meaning light, and synthesis, meaning putting together with light. The leaf takes water from the ground, carbon dioxide from the air, and sunlight from the sky, and turns it all into sugar, energy, fuel. It's alchemy, really. Sunlight turned into life. And what does the plant do with that sugar? It grows. It stretches. It produces fruit and flowers and seeds. It becomes food for something else. That one beam of light, bounced off the sun's surface just 8 minutes ago, now lives on as a blueberry, or a stalk of corn, or a blade of grass beneath your bare feet. Every meal you've ever eaten was made possible by sunlight first. But plants aren't the only ones that respond to light's touch. You do too. When sunlight hits your skin, it triggers a cascade of responses. Cells deep beneath the surface begin to synthesize vitamin D, a molecule your body needs to absorb calcium, strengthen bones, balance hormones, regulate immunity. A quiet transaction. Light enters. Health blooms. Of course, not all light is gentle. Too much of it can burn, damage, age. Your skin knows this too. It adapts. Melanin, the pigment that gives skin its color, acts like a natural umbrella, absorbing ultraviolet radiation, dissipating it as heat. The more sunlight you're exposed to, the more melanin your body produces, a built-in memory of brightness. A tan isn't just a color, it's a story your skin tells. I've been touched by the Sunday, but light does more than shape skin and plants. It shapes time. Every cell in your body has its own clock, a circadian rhythm, a 24-hour cycle that tells you when to wake, when to sleep, when to repair, when to dream. And guess who sets that clock? Light. Your brain has a tiny cluster of cells called the suprachiasmatic nucleus, tucked deep inside the hypothalamus. Every morning, as sunlight touches your eyes, that nucleus receives the signal, day has begun. It adjusts your hormone levels, raises your temperature, makes you alert, and when evening falls and the light fades away, that same cluster says, it's time to rest. It releases melatonin. Your body cools. Your thoughts slow. Your eyelids grow heavy. All because light arrived and then left. It sets the rhythm of your days without ever making a sound. Even when you travel, crossing time zones, feeling jet-lagged and untethered, light is the force that gently pulls your rhythm back in line. You don't need a watch. You just need sunrise. And your body remembers where it belongs. But let's return now to that soft image, of light as something more than functional, because light doesn't just power and regulate, it soothes. Have you ever sat beneath a tree and let the sun flicker between the branches overhead? Have you ever felt the golden hour glow on your face? That amber hush just before sunset? Light has a texture, an emotion, a presence. Morning light is hopeful. Noon is sharp and bright. Evening is tender. Each shade says something different. Not in words, but in warmth. Artists have always known this. Painters chase the softness of afternoon light. Photographers wake before dawn to capture the blue calm. Architects angle windows to shape the way light walks through a room. Because light reveals. But more than that, it feels. It can make a room cozy or sterile, open or private, holy or homey. Light is not just about what you see, but how you feel while seeing it. Even in medicine, light plays a role. Doctors use phototherapy to treat jaundice in newborns, bathing them in blue light to help their livers break down excess bilirubin. Psychiatrists use bright light therapy to ease seasonal depression, reminding the brain that even in winter, the day still arrives. Lasers heal wounds. Infrared lamps reduce pain. Ultraviolet light purifies water. And in all of these cases, light enters gently, but changes things deeply. It doesn't shout. It doesn't force. It simply touches. And, in touching, transforms. Now, return to your room. Maybe there's a soft lamp glowing. Or maybe it's just the moonlight filtering through the curtain. Even that tiny amount of light, barely enough to cast a shadow, is still reaching you, still stirring the clocks inside your cells, still whispering to your brain, "This is night, let go." And if morning comes too soon, your body will know that too. A soft change in spectrum, from blue to gold, and your rhythm begins again. So tonight, as you drift off, remember this. Light is not just a flash or a beam. It is a touch, a language, a rhythm. It feeds the trees, colors your skin, tells your cells when to rest, when to repair, when to remember. Even in your dreams, light has left its trace. A warm shape, a timekeeper, a companion. You don't need to see it. It's already working. And you, gentle being of biology and brightness, you are already responding. Light, for all its grace and speed, doesn't linger. It touches, it moves, it vanishes. And yet, humans, ever curious, ever longing, have spent centuries trying to catch it. To trap a beam, hold a glow, freeze a moment of radiance and say, "Stay, I want to remember this." And so, we invented ways to capture light, not with nets or boxes, but with instruments of memory. Your eyes, a mirror, a glass lens, a roll of film, a sensor inside a tiny black rectangle in your pocket, all different shapes, but all designed for the same sacred purpose: to stop the flow of light long enough, to turn it into meaning. Let's begin with the oldest and most personal light catcher: your eyes. Two small orbs, set in your skull, made of jelly and nerves and water. They look soft, fragile, but they are astonishing. They receive photons, millions, every second, and convert them into electric impulses, not one by one, but in complex mosaics of contrast and color and shape. Light enters through the cornea, bends slightly through the aqueous humor, passes through the pupil, that little black hole in the center, and lands on the retina, a paper-thin layer of cells at the back. There, magic happens. There are two main types of cells that sense light: rods and cones. Rods are masters of darkness. They detect motion. They help you see at night. They don't care about color, only light and shadow. Cones, on the other hand, adore the day. They come in three kinds: sensitive to red, green, and blue. And from just those three, your brain builds every color you've ever seen. Together, these cells form a living, breathing camera, one that adjusts automatically, heals itself, adapts to new light within seconds. You carry them with you always, the original image makers. But humans weren't content with memory alone. They wanted proof. And so came mirrors, not just to reflect, but to study, followed by lenses, curved glass that bent light more precisely. Then came the camera obscura, a darkened room with a small hole in one wall. Light from outside would enter and project an upside-down image on the opposite wall. It was the first time humans saw light form a picture on its own. No artist, no brush, just photons and patience. But still, it was fleeting. To truly capture light, they had to make it stay. That moment arrived in the 1,800 second. Chemical-coated plates, long exposures, frozen faces in sepia and silver. It began with daguerreotypes, then film, then photographic negatives. Light would strike a photosensitive surface, and where it landed, a reaction would occur. Silver would darken, emulsions would shift, and suddenly, a moment became permanent. A smile, a skyline, a tree caught in autumn gold. Each photo a record of photons, tiny packets of history. Modern cameras work similarly, but now with digital sensors. Inside, a grid of tiny light-sensitive pixels waits silently. Each pixel counts how many photons strike it. It converts the energy into an electrical signal. The more light, the brighter the signal. Color is captured by placing a filter over each pixel: red, green, or blue. And just like your cones, the camera's brain mixes these signals to rebuild the world. A sunset, a laugh, a child looking up at the stars, all made of light, caught and remembered. But the camera is not the only trap for light. Mirrors shape it, telescopes stretch it, microscopes dive into its tiniest reflections. Laser cavities bounce light until it becomes coherent, a beam of perfect order. Fiber optics bend light around corners, sending messages through hair-thin strands of glass. Photovoltaic cells turn light into electricity. solar panels soaking in photons, spitting out power. All around you, light is being tamed, redirected, transformed, but never stopped. You see, light does not like to be held. Even in a black hole, where gravity swallows everything, light resists. It bends. It spirals. It slows. But only at the event horizon. The final edge, does it truly disappear? And even then, its absence becomes a signal, a shadow, a silence that still says, something passed here. Think of stained glass, how it catches sunlight, sculpts it into reds and blues and greens, and sends it dancing across the floor. That's not just color. That's light, filtered by memory, by intention. Someone shaped that glass, knowing how the morning sun would meet it. Someone designed that window to teach a wall how to glow. Even fireflies are light catchers. They produce light through chemical reaction, bioluminescence. But they flash it outward, knowing some eye will see it, some heart will feel it. Even the night sky is a gallery of captured light. The stars you see, many are already gone, but their light remains, still arriving, still flickering, proof that what glows, even for a moment, can echo for millennia. And what about shadows? They, too, are records. Light's memory of what stood in the way. A curtain, a tree, a person who once stood in front of the sundae, the silhouette on a wall, the shape on a photograph, the darkness cast across your pillow. Every shadow tells a story about where light could not go. And in that space, you find form, depth, presence. So tonight, look around your room, or just imagine it in the dark behind your eyes. The lamp, the mirror, the glass of water on the nightstand. Each one is catching light differently, scattering, bending, absorbing, sending back a message. You may not see it all, but your eyes are still listening. You are still remembering. You are always surrounded by the quiet choreography of photons, entering, reflecting, escaping. Light, caught just long enough to leave a trace. And maybe that's all we ever needed. Not to hold the light forever, not to freeze the sundae, but to know that for one small moment, we saw it. We shared its path. We opened our eyes. And even when it moved on, we had the image, the echo, the imprint. Sleep now, beneath this soft lens of memory. The world is still glowing, still reflecting, still revealing itself, one gentle photon at a time. Sometimes, even when you understand the science, it still feels like magic. You can learn that light is made of photons, massless particles traveling at the universe's speed limit. You can study how they bend through glass, split into color, interact with cells, and bounce through mirrors. You can memorize the spectrum, run the math, draw the diagrams. And yet, a sunset still leaves you quiet. A candle still makes the room feel warmer than its island. The stars still pull something deep from your chest. Understanding doesn't ruin the wonder. It deepens it. Because light is more than brightness. It's presence. It's memory. It's connection. You've walked with it now. From the flicker of a match in a cave to the tangled waves of radio and gamma. You've seen how it dances through nothing, weaves color into the air, touches skin, whispers to leaves, and tells your body when to wake and when to rest. You've learned how it can be caught, briefly, by an eye, a lens, a mirror, how even when it leaves something behind, a shape, a temperature, a story. And perhaps that's what makes light feel sacred. Not just that it illuminates, but that it arrives, always from somewhere else. always bearing news. Light is a visitor. It left the surface of the sun 8 minutes before it kissed your cheek. It traveled for 4 years from Alpha Centauri just to twinkle in your sky. It passed through the curve of your mother's eye when she first looked at you. It bounced from the mirror when you first saw your own face. Light carries time, not in clocks or calendars, but in memory. It remembers where it's been. It leaves traces. It helps you feel what once was, and sometimes what's still island. Imagine this, a room, years from now, where someone opens a photo album, and there you are, caught mid-laugh in a garden. Sunlight in your hair. That light touched you and bounced into a lens and was frozen in silver or pixels or ink. And now it touches someone else. They see the light that saw you. And for a moment, you live again. That's the quiet miracle. Light connects. Not just moments, but people, places, generations. It crosses distance and silence. It bridges the now and the before. And it does all of this without trying, without force, without fanfare, just by being, by traveling, by touching, by glowing, even when it's gone, and it's not gone. A rainbow disappears, but the memory of it stays. The candle burns out, but you still see its afterimage behind your eyelids. The sun sets, but you still feel its warmth in the ground. Light does not demand permanence. It only asks to be noticed, and in doing so, it teaches us something gentle, that maybe you don't have to last forever, to have mattered. You only have to arrive, to touch something, to be seen. So as you lie here now, soft in the glow of your own thoughts, and let the light settle, you don't need to remember every fact. You don't need to hold on to every term. Just know this. You are wrapped in light's legacy. Every cell of you has been shaped by it. Every moment of your day has been timed by it. Every corner of your world, seen or unseen, has been kissed by it. Light is with you, in the spaces you notice, in the spaces you forget, and even as your eyes close, it waits to return. So let go now. Let the flickers behind your eyelids fade. Let the stars drift just out of focus. Let the hum of this little bedtime journey dissolve into silence. And if you feel something warm, soft, comforting, maybe it's just the memory of light curling up beside you, ready to rest. Just like you, this has been Boring Science for Sleep. Thank you for joining me in the glow. And if you ever find yourself awake again, searching for calm, curious in the quiet, just come back. The light will still be here. Good night.